Hello, welcome back to another video in this video series on property graphs. So in this video, we'll look into extractors and retrievers in property graphs. So we'll give a high level overview of how you can define these extractors and retrievers, different retrievers. How can you plug into property graphs, and then after creating indexes, uh, when querying, how can you plug into the retrievers, different retrievers, right? So we'll not run any of these parts of the notebook. So we'll just give a walkthrough of how you can create them. In the next notebook, we'll use the same things and plug in the extractors and retrievers and for creating property graphs. So let's get started with it. So yeah, so we'll first start with how can you build and use property graphs. So you basically get documents, and then the LLM and embedding model, these are the default ones. You can still define them and set them and then include them here. So property graph index from documents of documents will create index, and then you can use it. So include text is like, as I said earlier in the previous video, you can return the nodes and along with the source text as well, or else you can just return the nodes as well. So include text includes the source text as well for these nodes. So and then retriever.retrieve will retrieve the nodes, and then you can even build the query engine and generate a response accordingly. You can save the index and load the index again, and also if you have already existing index, you can just get the property graph store from the graph store, and then vector store and LLM get the index, and again use it for the retriever as well as query engine purposes. So that's how you can build the basic property graphs. Now if you want to have different extractors involved in it, right, while creating property graph index, so you basically assign them as kg extractors. So extractor 1, extractor 2, we have seen implicit path extractor, simple LLM extractor, schema LLM extractor, right? So you can include all three of them, or any one of them as well as you like. Okay, and in fact, once you have the index created, you can insert the document, you can insert nodes, different nodes as well. Okay, so yeah, that's it. So let's look into these extractors now. So by default, if extractors are not provided, we'll use simple LLM path extractor and then implicit path extractor as well. Okay, and then max paths per chunk equal to 10. That means for each chunk we create 10 triplets, right? So this is how a simple LLM path extractor is created. Let's look into more in details here. So here is a prompt here for creating those triplets. Some text is provided below. Given the text, extract up to max 10 triplets in the form of subject, predicate, object on each line, and avoid stop words. Okay, this is a prompt. You send it to LLM along with the text chunk. It creates these prompts. It creates these triplets. Sorry. And then once you have this output, you can parse them, and you can provide the parse function as well, and then use that triplets and index them accordingly. So, and the next one is implicit path extractor. As we said, using the relationships of nodes, we can get implicit path extractor property graph created. So kg extractor equal to implicit path extractor will give you the implicit path extractor. So the next one is schema LLM path extractor. In this schema LLM path extractor, we impose what are the entities, relations, and relations between different entities possible. So as seen here, so these are the entities possible: person, place, organization, relations, part of, has, worked at. And then you can create the schema. Okay, this place has person, person is part of place, person worked at, organization. So these are the only edges possible. So we have imposed it now. Right now, when we pass LLM and possible entities, possible relationships, validation schema, and so if it is false, will so the strict parameter true. If false, will allow triplets outside of the schema as well. Okay, and then maximum paths per chunk, which is a number of triplets per chunk, right? So you define these entities and then validation schema and the relations. Only these are possible, and then schema LLM path extractor will just create them, nothing else. And then once you have them, you can use it for retrieval and querying, right? So we have different retrievers, starting with LLM synonym retriever, vector context retriever, and text to cipher and cipher template retriever, right? So different retrievers are available. So you can use different retrievers and then create a query engine and retriever as well, right? So yeah, so I've seen LLM synonym retriever retrieves nodes based on keywords and synonyms with exact string match, but these are generated by LLM from the query. And vector context retriever uses embeddings of the text nodes as well as graph nodes. Text to cipher retriever basically it creates cipher query from the user query and extracts the nodes. For cipher template retriever, it extracts the parameters available in the cipher templates and then gets the data. And the custom page retriever, it's a custom retriever that we can combine different retrievers. Let's say you want to combine vector context retriever and text to cipher retriever, or multiple of these retrievers, or maybe you want to use re-ranker on top of it. You can use custom page retriever. So here, yeah. So here, for example, I have vector context retriever and LLM synonym retriever, and then define the retriever, and then you can retrieve. So let's see how each of these retrievers are defined, starting with LLM synonym retriever. So here is the prompt: given some initial query, generate synonyms or related keywords up to a maximum number of keywords in total, considering possible case of capitalization, plural, common expression, etc. Provide all synonyms or keywords separated by symbols, and node result should be in one line separated by specific symbols. So here is a query, and then the keywords are extracted based on this symbol. You parse it and then get the possible keywords. So here are the different parameters for synonym retriever, right? So yeah, and then vector context retriever basically uses embeddings, as I said. So same way, you need to pass index, embedding model, you want to include source text or not for embedding, and then similar top can other parameters, and then create a retriever accordingly. For text to cipher, it basically creates cipher query for the given query based on the fields allowed. So yeah, so we have a response template and what are the allowed fields, and text to, and then again text to cipher template. So accordingly you can provide all these parameters into the text to cipher retriever and get the retriever done. Similarly, for cipher template retriever, we have this cipher query. So you need specific parameters, right? The chunk mentions, right? And then basically create, get these parameters, send it to cipher query and get the data. So cipher template retriever takes the cipher query and then get the parameters and get the retriever ready. So you can this is a parentic class to represent the params for our query. The class feeds are directly used as params for running the cipher query. So here is a description, a list of entity names or keywords to use for lookup in knowledge graph basically. So this will create the template retriever, and as you have all these different retrievers, now what you can do is you can just plug in, define these retrievers and plug into the PG retriever what are the sub retrievers, okay, and create the retriever accordingly and then start querying. So this is how you can define different extractors and retrievers, and using property graph you can start querying. So in the next video we'll look into how you can use these retrievers and extractors and customize your property graph in and make it customizable. See you in the next video. Thank you.